Welcome to this channel where I will be teaching you guys how to do math. And in this video, we will be talking about topics 2.13 through 2.15. This is AP Pre-Calculus. Some of y'all may be taking this course, and these topics cover logarithmic equations and how to solve them. So in this video, we will be checking that out. We'll be seeing how to solve logarithmic equations. And yeah, let's get right into it. So right here, we have a log of 10x minus 1 equals 2. So if we have a log of 10x minus 1 equals 2, remember, one of the logarithmic properties is log of BA equals C, right? So this can be turned into a B. C equals A. Remember, guys? I don't know if your pre-calc teacher taught you this, but yeah. So here in this example, we have a 10, which is the base. So you get 10, 2, because that's the C. You put the C as the exponent. Then you get the A, which is x minus 1, like this, right? So then what's 10 squared? You get 100 equals x minus 1. You get plus 1 on both sides. 101 equals x, and that's the answer. Okay, so then now we have to find the domain of this right here, which is x minus 1 is greater than 0. So this right here, this what's inside the parentheses has to be greater than 0, right? So so it doesn't cancel out the log. We do not want a negative number or 0 to be here because it's gonna ruin the log. So how do we do this? We do plus 1 and plus 1 on both sides, and you get x has to be greater than positive 1. So, and then we, since we found the, the solution of x to be 101, obviously we know that 101 is greater than 1. So we don't have extraneous solutions, and this is the answer. So here we have another problem for log 3 2x equals 8, right? So let's see what we got here. Here we divide by 4 on both sides. Okay, so we divide by 4. Then we're left with log of 3. Because remember, guys, we're treating this basically as an equation. So if you were, something simple, like if you had like 2x plus 1 equals 8 or something like that, you would do the same thing. So we are treating that. We are treating these logarithmic equations just like we were to treat some, algebraic equation like this one. So 4, you divide 4, right? 2x equals 2, right? So then we have, we do the same thing we did here, right? Because we do 3, 2 equals 2x. We know 3 squared, that is 9, that's 9. And then that equals 2x, right? So now we divide 2x because we're trying to isolate the x, and then we get x equals 9 over 2, right? So that's the answer. We know that, x, the domain of this one has to be x greater than 0, because if you can't have 2 0 because that equals 0, and, you don't want 2 negative 1 because that's a negative, and we don't want negatives. We want something positive. You have to be positive. So 9 over 2 is positive, so we know that's the answer, and there are no extraneous solutions. So let's see, we have now ln x over 3. Remember, guys, ln, that's a natural logarithm. And this can be written as log of e. Remember, that's, ln is just log of e. So then we have ln x over 3 plus 4. So here we already have minus 4, ln x over 3 equals 3, right? So what do we do here? So remember, we have log e x over 3 equals 3. So e to the third equals, because remember, back to the original, principle, that's what we have. So x over 3. So then here we have, you just solve it like a simple algebra equation, right? You multiply 3 on both sides, 3, and x would be equal to 3e to the third. I'm sorry guys if you guys didn't catch that, but x would be equal to 3 times e to the third. So that would be the answer to x. You could calculate this in the in the calculator, but yeah, of course x we know that has to be greater than 0, because we do 0 divided by 3, that gives you 0, so you can't have that, and you can't have a negative, so x has to be greater than 0. And of course we know that 3e to the third is greater than 0, so yeah. All right, so here we got log of 10x minus log of 10 3 equals log of 10x minus 4. Right. Okay. So what is log? Okay, so remember, go back to the logarithmic properties. We have log we have two logs with the same bases, right? And they're being subtracted. So what do you do here? What do you do when they're being subtracted? You just do, remember, what do you do when two logs are being subtracted? You divide them, right? So you do log of 10x divided by 3 equals log of 10x minus 4. So now that we have, both of the logs have the same bases on each side of the equation, we have x over 3 equals x minus 4, right? So we have, we do the same thing we did here, and we multiply by 3 on both sides, right? Remember, when you multiply by 3 on both sides, you're multiplying the whole side. Don't forget to, to multiply by the x here. So we do x equals 3x, because we're multiplying by the x, but, we're multiplying by the whole equation, minus 12, right? So then we do minus 3x. We just solve it like a simple algebra equation, right? So we have, this is a 1 minus 3, you have negative 2x equals negative 12. You have you divide by 2 and you get x equals 6. And of course we know that x has to be greater than, this is the domain right here, x has to be greater than 0, x has to be greater than 4 right here. And yeah, those are the domains, and x and 6 is greater than 4. So yeah, that's what we have there. All right, guys. So now we have ln x plus 2 plus ln x minus 1 equals ln. So, you notice how all of these are ln's, which means they have the same base, right? So let's see what we, can get. All right. So this right here just means x plus 2 and x minus 1, because, you're adding two logs with the same base, because remember, this is just log of e. So when you're adding, you actually multiply whatever is in, is in the parentheses, right? So yeah, so here you just have this 3x plus 13, because they're all the same. But now you have to multiply these, okay? So what do you do here? You distribute, right? You do this, boom, you get x squared minus 1x plus 2x, and then you get minus 2, because you distribute, all right? So x squared minus 1x plus 2x, you get plus x minus 2. So this is a quadratic equation that we just derived from this, right? So then we have equals 3x plus 13. All right. So then now we are supposed to solve for this, right? So here's what we do. We do minus 3x, and then we do minus 13, because we, remember, we're trying to find the x, right? We are trying to solve for x. So since we have a quadratic equation and we have another, another kind of, and we have this in the other side, then we have to set it equal to 0, right? So that's what we need to do. We have to set it equal to 0. Okay, also let's take a note of the domains real quick. We have x has to be greater than negative 2, x has to be greater than 1, and x has to be greater than, Here we have 3x plus 13 greater than 0. You do minus 13 minus 13. You get 3x greater than negative 13. You divide by 3. And you get negative 13 over 3. X is greater than negative 13 over 3, right? So we know that the domain is x has to be greater than negative 13 over 3. Okay, so then you have x squared. You have 1. This is 1 right here. 1 minus 3x. This is minus 2x. Okay, so then we have minus 2 minus 13. You have minus 15. And we set this equal to 0, right? So now let's of course now we have to factor, right? Because we need to find the x's. So how do we do that? So I don't know if you guys have learned factor. Hopefully you guys have. This is what you have to do before you enter into pre-calculus. So hopefully you have, factored. All right. So then we have a 15 here, right? And we have, because 1 times 15. This is 1 times 15, right? And then so 3 times 5. We already found the factors that add up to the b, right? So you have x squared. You have plus 3x minus 5x, because 3x minus 5x gives you negative 2x, minus 15. Then you find, the factors. So you have x, then you have negative 5, you get x minus 5, and you get x plus 3, right? So then you have x equals 5, and x equals negative 3. I'm sorry if you guys are hearing some background noise. Sorry about that. But yeah. All right. So we have x equals 5 and x equals negative 3. So this is what we got when we factored it, right? Because we're trying to find the x's. So these are the x's that we found. X equals 5, x equals negative 3. But remember, we have to go back and check for our domain. We already know x has to be greater than negative 2, x has to be greater than negative 13 over 3, and x has to be greater than 1. So which of these two is compatible with our domain? Well, it is x equals 5, because x equals 5 is greater than all of these. It's greater than 1, is greater than negative 2, is greater than that. However, negative 3 is not greater than 1, and it is not greater than negative 2. It is greater than this, but remember, we have to factor in all our domains. So the answer would be x equals 5. But we're not done yet. It says at the top, check for extraneous solutions, right? So right here, we would have x equals negative 3 as an extraneous solution. And why is the case? Because if we were to plug this, this x back into our equation, we would get an error. It would not work. And yeah. However, if we were to plug this, we would get an answer and it would work. So yeah. Okay, guys, I will continue with the other ones later, but this is what we've gotten so far. This is solving logarithmic equations. I hope you guys have a nice time. I hope you guys have learned and can implement this in your next class.